Okay, one postulate says that you have to replace every dynamical variable by its corresponding operator. Then operators are such that sometimes they commute and some operators they do not commute. Now here, if you have two operators A and B, then this bracket says that AB, this bracket means, square bracket means AB minus BA, this is known as commutator of A and B. And if A and B, that is commutator, is equal to 0, that is this is equal to 0, then A and B, they commute with each other. It means that if you are going to make measurements on two quantities, A and B, then there will be no uncertainty in their measurements if you are making simultaneous measurement on both of them. On the other hand, sometimes operators do not commute, that is A and B commutator is not equal to 0. In that case, it means that A and B are such quantities that they cannot be measured with the same level of accuracy simultaneously, and they will show uncertainty product. Okay? Now, as an example, I am taking x component of a position of particle and its x component momentum. So I can write it like this is square bracket. So I want to check whether they commute or not. They can be written like this. Then I operate this quantity on a wave function psi. So I write psi here, I write psi here, okay? Then look, this operates on that, this operator also operates on that, okay? Let's evaluate first. This is x, and you know x component of momentum in quantum mechanics is written as minus IH bar delta over delta x, and it is operating on psi, and that is the result minus I x, okay? This x is outside the operation of delta over delta x, so you have only single expression from that. However, situation is not the same here. Minus IH bar and this minus minus become plus, and this is operating on 2 because psi is also function of position, okay? So u into v, u into derivative of this plus derivative of this into v, and you see this becomes IH bar x delta psi over delta x, which is similar like that one, so they cancel each other. This is with minus sign, and this IH bar and delta x cancels psi. So you can cancel psi from both sides, and answer is x px is equal to IH bar. Now that is mathematics. Now what physics says? As I told you before, that since the position operator and momentum operator, they do not commute, answer is not 0, hence they cannot be measured with same level of accuracy simultaneously, and therefore they will show uncertainty product. And you have seen it in your FSC and BSc, okay, that delta x, delta px is of the order of h bar, or h bar over 2, whatever it is, doesn't matter, it is just a constant. Now remember one thing, x delta px of the order of that, it means that if you make this certain, then this will become uncertain, and if you make this certain, then this will become uncertain. From everyday life, I can give you an example. An example is that if I am standing here, a person is there, and I am looking like that, and somebody asks me, okay, simultaneously, at the same time, who is on your left and who is on your right. Now, if I look on this side, I'll be sure who is here, but I will be not sure that who is there. So uncertainty on this side increases, but uncertainty on this side decreases because it is more certain. And if, say, I look there, then this will become uncertain and this will become certain. So two things simultaneously, you cannot predict correctly. Okay? So here, one will be uncertain. So that is the thing. Now similarly, I can show you that if you take y with px, now just look at that, what happens? This can be written as y px minus x py. Minus ypx minus pxy, right? And okay, let's operate on as before, ypx minus pxy on psi. This will give you y minus I h bar delta over delta x, right? Delta over delta x psi minus and minus I h bar delta over delta x y psi. Challenge. This is equal to minus I h bar y delta psi over delta x, minus minus become plus, I h bar u into v, u that is y, right, and then delta psi over delta x plus derivative of this, which is partial derivative of y with respect to x is what? 0, and so that is 0, this is 0. These two are being the same, they cancel out, and hence ypx is equal to 0. It means that, okay, you will never see an expression like that. Delta y, delta px is of the order of h bar. No, never. You will never see that. It means that y component of position of particle does not commute with x component of momentum of the same particle. It means position y of the particle and x component of the momentum, they can be measured with accuracy simultaneously and there will be no uncertainty in them. So remember this, that when you have x and px, y and py, z and pz, they do not commute. Okay? So from here, the conclusion is that this is equal to y py, it is equal to z pz, right? And similarly, ypx is equal to 0 mean z, this is ypx, you can take x py and you can take z py, etc., etc., they are all 0. Did you get it? आपको समझ कुछ आ गई है कि what I am saying, the conclusion is कि whenever two operators they commute with each other, then they do not have uncertainty product. They do not have uncertainty product. When they do not commute, then they have uncertainty product. They do not commute. ये commute नहीं कर रहे. Right? So that is the essence of that. अब you, as you say, you know, your own practice, you can check what happens if you take X component and Y component. What is the answer for that? कि आप जो है X component measure कर रहे हैं, ये आपको किसी एक्सरसाइज में भी हो सकता है मिल जाए ये बुक में, लेकिन मेरी नज़र से अभी नहीं गुजरा, लेकिन आई हैव सीन इट इन मैनी बुक्स. ओके, मैंने और जगहों पर देखा है कि ये जो है so this what it says कि XPX does not commute. अब on page number, you please note it down, 95, page number 95, page 95, article is 2.4.5. This says uncertainty relation between two operators. He is now generalizing things. Uncertainty relation between two operators. अच्छा, इधर तो मैंने कह दिया कि भाई अगर कम्यूट करें तो फिर क्या है, अनसर्टेनिटी रिलेशन नहीं है, और अगर कम्यूट न करें तो फिर अनसर्टेनिटी रिलेशन है. अब इन दिस आर्टिकल ही इज गोइंग टू जनरलाइज दिस थिंग. हाउ इज जनरलाइजिंग इट? He says that if there are two operators A and B, and they do not commute, तो फिर क्या है? Then delta A, delta B is equal to 1/2 A and B. और ये भी है, कम्यूटेटर भी है. ठहर जाओ, पहले कम्यूटेटर है और फिर उसकी एवरेज वैल्यू है. ओके, ये उसका प्रूफ दिया हुआ है ऑन पेज 95, 96. यू हैव टू हैव एन आई ऑन दैट. उसको एक नज़र देख लो कि आपको क्या कह रहा है. ओके, हाउ इट इज़ बीइंग प्रूव. कह रहा है कि इफ़ टू ऑपरेटर, जनरल ऑपरेटर्स, आई एम नॉट टॉकिंग अबाउट मोमेंटम एंड पोजिशन. ही सेज इफ देयर आर टू एनी जनरल ऑपरेटर्स A and B, they do not commute, then delta A delta B is equal to commutator of this, take its average value and then take its modulus, divide by 2. Based on this, he has derived this. Delta X delta Px is of the order of h bar over 2. Delta Y delta Py is of the order of h bar over 2. Delta Z delta Pz is of the order of h bar over 2. अच्छा जी, very powerful relation. if A and B commute, what will happen to this? 0. तो ये 0 हो जाएगा. If they do not commute, तो फिर उसका आंसर आएगा 1/2. A and B मतलब है इसका डिफरेंस जो भी आ रहा है, you will write here whatever is the difference of the two operators, you write here, take its average value, divide by 2. Now what we have done, we have, that is IH bar, क्या है, x px is IH bar. अब इसकी एवरेज वैल्यू ले ली है, ठीक है, और 1/2 कर दिया. अब एवरेज वैल्यू लोगे तो क्या हो जाएगा, ये खुद आएगी क्योंकि आप इसको इस कॉन्जुगेट से मल्टीप्लाई करोगे, ठीक है, और फिर ये चीज़ आ जाएगी तो डिवाइड बाय 2 ये चीज़ आ जाती है आपसे, बिल्कुल इसी तरीके से. Okay, so you can derive these things directly if you know this result. This is a very powerful result. Okay, that is one thing. Second thing is that you can look at page 127. Page 127. और 127 पेज, ऑन पेज मैं लिख देता हूँ, खैर खैर छोड़, पेज 127. He has written 3 relations like this: x px is equal to IH bar, y py is equal to IH bar, z pz is equal to IH bar. When you go home, try to check कि what is the answer here if you change the order. घर में जाकर px और x कैलकुलेट करो कि क्या आएगा. What you guess? What? Well, I think there will be minus sign there. There will be minus sign there. Okay? कि अगर आपने px को इधर लिख दिया, x को उधर लिख लिया, तो वो जो एक्सपेंशन होगी उसमें वो माइनस कैंसिल नहीं करेगा, and there will be minus sign there. Okay? So that is one result of this, कि भाई ये जो है ये इक्वेशन दी हुई है उसने कि these 3 are commutation relation of the various component of, and then he has shown that xpy is equal to xpz, ypx, ypz, zpx, zpy is equal to 0 because they commute with each other, and hence that is the relation. Okay, now let me write a general relation. General relation is like this.